Hi guys, today we're learning how to use matrices to solve systems of equations. When you get to pre-calculus, you're going to learn a different way to do it, but this is the way we're going to use it for now. Okay, so first thing we're going to talk about is turning our equations into matrices. Okay, so here we have a system here: 5x plus 7y equals 11, and 3x plus 8y equals 18. Right, so you can see here we split the parts with coefficients and the constants. Okay. Then what we can do is we can also now remove the x and y and put it into a variable matrix. Right? So here is just the coefficients: 5, 7, 3, 8, 5, 7, 3, 8. And then this is the variable matrix. Since when we're multiplying, it goes this row and then this column, right? The 5 goes with the x, the 7 goes with y, the 3 goes with the x, the 8 goes with the y. So that's why we're going to write it in this way: x and then y, and then equals that constant matrix here. Okay? So we're going to practice by rewriting each of these matrix equations, into a matrix equation. Okay? So let's start with example first. We're going to write our coefficients. So here are my coefficients: 5, 6, 3, and 2. Sorry, it should be -6, 3, and 2. So here is my coefficients: 5, -6, 3, and 2. Okay. Then I'm going to write my variable matrix. Since these goes with x and these goes with y, I'm going to write x first and then y, right? Because when we're thinking about multiplying, it's 5x minus 6y, 3x plus 2y. Okay? Then equals my constant matrix, which is -47 and -17. And there you go. Good. So why don't you check your progress 1, and then once you're done, come check your answer. Okay, this is what you should have gotten: 2, 4, 3, and -1 for your coefficients. Again, this -y means -1 times y. Okay. Then your variable matrix, xy here, equals, and then your constant matrix, which is 7 and 6. Okay. So now let's move on to example 2. So the molecular formula for glucose is C6H12O6, which represents that a molecule of glucose has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. One molecule of glucose weighs 180 atomic mass units, or AMU, and one oxygen atom weighs 16 AMU. The formulas and weights for glucose and sucrose are listed below. We're going to write a system of equations that represent the weight of each atom. Okay? So we're going to make C the weight of a carbon atom, H the weight of a hydrogen atom, and O the weight of an oxygen atom. Okay, so starting with glucose, it has 6 C's, 12 H's, and 6 O's. However, we know that an oxygen atom weighs 16 AMU, so I can replace this here. Instead of an O, I know it weighs 16 atomic mass units, and that equals a total of 180 atomic mass units. Okay? So this is glucose, C6, H12, and 6 O's, but O we know is 16 atomic mass units. Okay, so let's simplify here. 6C plus 12H. 6 times 16 is 96, so this is 96. Okay. Then, when I subtract the 96 over, I can simplify to 6C plus 12H equals 180 minus 96 is 84. Okay. So now let's do the same thing for sucrose. So sucrose here is C12, so 12 C's, We have 22 hydrogens, so 22H. And then it has 11 oxygens, so 11 O's, except we know that an oxygen atom weighs 16 atomic mass units, so we can put 16 here. And the total of all of these atoms, the atomic weight is 342. Then I'm just going to simplify, so 12C plus 22H. 11 times 16 is 176. And then I'm going to move the 176 over by subtracting, and this leaves me with 12C plus 22H equals 342 minus 176 is 166. So my system of equations is this for glucose, 6C plus 12H equals 84, and this for sucrose, 12C plus 22H equals 166. Okay. And now I can write a matrix equation by taking the coefficients, the constants, the coefficients, the variables, and the constants. So that will become, for coefficients, 6, 12, 12, 22. For my variables, that's C and H, because 6C, 12H, 12C, 22H. Equals my constants, which is 84 and 166. Okay. So why don't you try check your progress too, and once you're done, come check your answer. Okay, this is what you should have gotten for the system of equations. 3C plus 8H equals 44 for the propane, and 4C plus 10H equals 58 for the butane. Then, writing it as a matrix equation, it should look like this. Here's your coefficients, 3, 8, 4, and 10. These are your variables, C and H, and these are your constants, 44 and 58. Okay, so now let's move on to our last example, which is actually using this to solve them. Okay, so let's get started. Okay. So here, solving our systems of equations, right? So this is what we think about in terms of if they were just our regular equation, ax equals b, we would get rid of it by dividing by a or multiplying by its reciprocal, which is 1 over a, right? Those are inverses. Okay? As a result, the 1 over a and the a cancel out, leaving us with just 1x, and this becomes the inverse of a, which is 1 over a times b. Okay? Using the same idea, we can do that with our matrices, right? So our matrix equation is in this form. So if we multiplied it by our inverse, the inverse and the matrix will undo each other, leaving us with whatever our coefficient equals to when we do the inverse times our constant. Okay, you just need to, yeah, there you go. Okay, so now let's get started. Okay, so the first thing I'm going to do is I'm going to rewrite this into our matrix equation. Okay, so I'm going to do, let's write it down a little. 6 times, 6, 2, 3, negative 8. And then x, y. Okay, I'm going to leave some space later to put my inverse in. And then this is 11 and 1. Okay, so here I need to do the inverse of this. Okay, so I'm going to do the inverse. Let's do it in pink, right? So if you remember, your inverse is 1 over AD minus BC. So 6 times negative 8, that's my AD part, minus B, which is 2 times C. And then the matrix part, A and D are going to switch places. So this is going to be negative 8. This is 6. And B and C are going to change signs. So this is negative 2 and this is negative 3. Okay. Let's just simplify this here. 6 times negative 8 is negative 48, minus 2 times 3 is negative 6. Okay. So that negative 48 minus 6 is negative 54. And then I would just keep writing this. Okay. So now, since this is the inverse of this, to undo it, I'm going to multiply them together. So it's going to be negative 1 over 54. Fit it in, so negative 8, negative 2, negative 3, 6. What you do to one side, to balance it, you need to do it to the other side. Okay, so because these two are inverses, they're going to undo each other. So basically, I don't have to worry about that anymore. And it just results in xy. Okay. And then on this side now, I am going to multiply. So I'm going to leave my negative 1 over 54 out in front for now. And so let's multiply. So it's going to be this row and this column. So negative 8 times 11 minus 2 times 1. Negative 8, 11, negative 2, 1. Okay. Then this row and the column, so negative 3 times 11 plus 6 times 1. Okay. So leaving my scalar still up in front. Negative 8 times 11 is negative 88. Negative 2 times 1 is negative 2. Negative 3 times 11 is negative 33. And 6 times 1 is 6. Okay. Negative 88 minus 2 is negative 90. Okay. 33 plus 6 is negative 27. Okay. And then multiplying it in, this becomes 90 over 54. The negatives cancel each other out, and then the 27 over 54. Okay. 90 over 54, both divisible by 9. So that'll be 10 and then 6. 27 and 54, both divisible by 27, so this is 1/2. Okay, I can still simplify my 10 over 6, which is 5/3. And 1/2. Okay, so that means, running out of space, x equals 5/3, y equals 1/2. So the ordered pair is 5/3, 1/2, or 1 2/3 and 1/2. Okay, there you go. Sorry. And there you go. Okay. So now, let's try B. So let's do a different color maybe. Okay. So here is 6, negative 9, 8, negative 12. Okay. Coefficients are A and B. Okay. Constants here are negative 18 and 24. Okay. And then finding the inverse of this, or inverse of this. Okay. It's going to be 1 over A times D, so 6 times negative 12, minus B, which is negative 9, times C, which is 8. Okay. Then the matrix part, A and D are going to switch places, so negative 12 here and 6 here. And then B and C are going to switch signs, so positive 9 and negative 8. Okay, let's simplify this. 6 times negative 12 is negative 72. Negative 9 times 8 is negative 72, and then the minus will put plus 72. So this would be 1 over 0. Okay, and so this doesn't work, right, because this is undefined, so there is no inverse. And so what it means is this is a unique solution. There's no unique solution. And so really, if we were to graph it here, we can see there's no solution because they are parallel. Okay, so this would just be, so there's no inverse, no solution. Okay, so why don't you try check your progress 3A and 3B, and once you're done, come check your work. Okay, for 3A, your answer should have been 2, 1, and for 3B, it should be no solution. If you got that right, you can move on to your homework. If not, here's your explanation. Okay? So the first thing I did is I rewrote this system of equations into my matrix equation. So this is my coefficients, -2, 3, and 4, -8. And it was x, y. These are my constants, -7 and 16. Okay. Then, since I want to get rid of this matrix, I'm going to find its inverse, so that way they can cancel each other out. Okay. So it's going to be 1 over the determinant, so that's a times d, so -2 times -8, minus b times c, 3 times 4. Okay. Then a and d are switching places, so that's why -8 is here and -2 is here. And b and c are changing signs. Okay. -2 times -8 is 16. 3 times 4 is 12, so 16 minus 12, that's 1/4 here. And we wrote it, so what you do to one side, you do to the other. Since these are inverses, they will cancel each other out, leaving me just with x, y. And then I'm going to multiply, so this row and the column. So -8 times -7, -3, 16. -4 times -7, -2, 16. Okay, simplify, this becomes 56, this is 48, so 56 minus 48 is 8. This is 28, this is -32, 28 minus 32 is -4. A fourth of 8 is 2, and a fourth of -4 is -1, so this is my x, this is my y. So x is 2, y equals -1, and so if I were to graph these, they would touch at the point 2, 1. So 3b, I started the same way. I rewrote this into my matrix equation. So this is my coefficients, 2, -4, 3, -6, 2, -4, 3, -6. Here are my coefficients. Sorry, here are my variables. And then this is my constants. Okay. Then to cancel with this, I'm going to do the inverse. So it's going to be 1 over the determinant. So 1 divided by a times d minus b times c. So 2 times -6 minus -4 times 3. And then here, I switched a and d and changed the sign for b and c. Okay. 2 times -6 is -12. Minus a negative makes it positive, so +4 times +3 is +12. -12 plus 12 is 0, so since that's 1 over 0, this is undefined. It means there is no inverse matrix, which then means I have no solution. Okay. That's it for today. Have a great rest of the day. Bye, guys.